So in our lesson 3.2 today, we actually have two learning goals, and we're going to do the first one, the second learning goal I've written up on the board first. I can determine the domain and range of relations and functions. Well, we're only going to worry about relations on this, front page because we're not going to talk about what a function is until we get on the back side. So a relation, I want you to circle that. This is something, it's like a vocabulary word you should know. A relation is a set of ordered pairs. What do I mean by ordered pairs? What do ordered pairs create for us? You did an assignment after that last quiz on ordered pairs. What are they? They're what you use for graphing. They're points on the graph. They have an x value and they have a y value. They're in parentheses, and we have an x value and a y value. But ordered pairs can be written in a variety of ways. They don't always have to be written in parentheses with a comma between them. They also can be given in a table, and we can show the relation in a mapping diagram. We can show it in a graph. We have all those kinds of options for doing it, okay? So I'm going to let you, after we, I'm going to actually go through this. Here's our first one right here. So I want us to, let's number this. This is number one, okay? Not number one down here, but our number one up here that we're going to just talk through. We have the following relation. It has how many ordered pairs in it? How many ordered pairs does that relation have? And it's in a table form. How many ordered pairs does it actually have? 4. We have one right here, we have one here, we have one here, and we have one here. There's an x value that can be put together with a y value. When we are giving the domain and the range is what we're doing, it says up here the domain, and this is another thing I want you to put a box around. The domain is all the x values, all of the x values. So you're going to take all of the x values from the points, from the ordered pairs, from the table, wherever they're at, and you're going to list them as the domain. So in this first one here, here's our domain for this one. And notice that what it does, it says capital D just to represent domain, has a colon, and then it has these fancy little brackets that I call, they're kind of tricky to make sometimes, but I call them, like if you make them as a C, and then a little V lying on its side, and then another C below that, that's really what it is. It's like a half circle or a C, and then a V lying on its side, and then another C below that. And then we're going to be practicing writing them. And so notice what they did. They wrote the x value from each of these points, 3, 4, 5, and 6. Okay, one thing we don't do, and this one we don't have to worry about it, but we never repeat the x value. So if you have an x value used more than once, you only put it in the domain one time. And then let's also put a box around this. The range is all of the y values. The range is all of the y values. So the domain is made up of the x values. The range is made up of the y values. And notice, when they wrote the range, again, they used the first letter of the word, and they capitalized it, used a colon, used those fancy brackets to show set. That's set notation, we call it. And we list all of the y values with no repeating going on. So notice there's 4 members in the domain, but there's only 3 members in the range. Why are there only 3 in the range? Based on what I just said about repeating.
Because there's 2 twos.
Yeah, there's 2 twos. We don't need to list them both. We just need to say the range is made up of a 1, 2, even though it's in there twice, and 3. Okay? So do not list 2 twice in the range, it shows us here. Okay, when it is given to us, so that's getting it from by being able to get the domain and range from a table. When it's given to us in a table, we just have to pull the x values out and make those our domain, pull the y values out, make those our range, with no repeating going on in either. Well, the other choice we have is what if they give it to us as a graph? What if they give it to us as a graph? Now, we have to be able to do, first thing we want to do is decide, is it a continuous graph or a discrete? What kind of a graph is number 2? Is that continuous or is it discrete? By the way, I want to point out to you where the graph actually is because there's lots going on here. There's the graph. It's continuous, isn't it? Let's write that. Because when you have a continuous graph, that means everything on there counts. There's all kinds of points between the start and the end of that line. There's so many points on that line. We can't begin to list all of those x values or all of those y values. So notice what they did, something that we just got done doing. They wrote the domain and range as compound inequalities. I want you to add those little set notations to this, though, with your pencils. I want you to put that fancy little bracket at the beginning and at the end of domain, beginning and end of range. We always want to list them in set notation. So basically, remember the domain values are all the x values. We have to have an x in the middle of our compound and inequality. And we're going to say the first x value is at 2. The last point on here has an x value of 7. So notice they used 2 and 7 as their endpoints. Range are the y values. So now we got to look, how low does it go? What's the lowest y value? The lowest y value is 3, and the highest y value is 5. So our range is between 3 and 5 with a y in the middle this time because the range is made up of y's. So getting it from a graph, if it's discrete, then we're going to be able to list them. But if it's not discrete and continuous like this one is, we're going to have to write compound and inequalities. And then from the mapping diagram, we're actually going to do these when we make them starting, I think we start to do that tomorrow. We're going to always make them from least to greatest in both of them. But we're just going to go with what they have here. This is our, when they always give the x first. Would you put that above that oval? They always give the x first in a mapping diagram, and the y is second. So the x's are 7, 5, 2, and 0, like they listed here. The y's, our range, are 3, 6, 7, and 10. There was no repeating going on. What do the arrows mean? Well, they mean that if you were going to write this as an ordered pair, 7 is mapped to y value 3. This is really ordered pair 7, 3. That's what that arrow means. They're being mapped to each other. They're a pair. They're an ordered pair. Okay, let's go do some practicing there. Number 1 below, we have a table. It says find the domain and the range of each relation. And we always are going to go from least to greatest when we're listing them. So let's start with the domain of this one. Domain is made up of these, so start with your fancy little set notation. What's the domain? -2,
-1,
-1,
0,
0, and 1. And we're ready to close our set. Those are all the members of our domain. Okay, now let's do our range. Least to greatest, no repeating. Not necessarily the order that they are in there. So, what would be our first member of the range? 0. Next, 1 and 4. Do we need to say the 4 again? No, we don't want to say it again. Okay, there we go. Okay, you go try the next one. Now they give it to you as ordered pairs. Remember, ordered pairs go like this: x, y. So go ahead and list the domain and the range, least to greatest. No repeats.
Wait, so x is always before the y value, right?
In the ordered pair,
Yeah.
yeah, x always is first, y is always second. Okay, Samuel, what's our domain?
-5, -2, and 4.
Good job. Andrea, what's our range?
5, 6, and
5, 6, 12, and I'm going to run a room for my bracket there. 5, 6, 12. Good job. Okay. Questions on either of these at the moment? Okay, number 3 is given to us as a mapping diagram. Remember, what did I say the first oval represents? X values. What does the second oval represent? Y values. Okay, so let's go ahead and write our domain first. Zero, 1, 2, 3, right? Least to greatest, no repeating. There were no repeats anyway to worry about. Good news is this is what's already given to us in least to greatest in the mapping diagram in the oval. How about the range? What would we write for that one, Blake?
5, 6, 7.
Yeah, we're going to start at the bottom of this one because the smallest one is at the bottom of our oval. So 5, 6, 7, and 8. Okay, you go ahead and try number 4 on your own. Do the domain and the range for number 4. Let's see how that turns out. Maisie, what's the domain?
-5, -4, -3.
Good job. Least to greatest. -5, -4, -3. Okay, how about the range? What's the range? Holly?
10, 11, 12,
Okay, good job. 10, 11, 12, and 13. How many ordered pairs are there really in this relation? 4. Yeah. We have 2 of them that have an x value of -4. And they have those different y values. So there really are 4 ordered pairs represented. So in a mapping diagram, notice there's no repeats going on either. So they did not do the -4 twice in the mapping diagram either. They said it once and then drew arrows, mapping it, saying, you know what, -4 has a y value of 11. And then there's another point that has an x value of -4 and it has a y value of 12. So there really are 4 ordered pairs there. So any questions? Before we go on to our tricky ones. These are the trickier ones. Okay, so here's what I'm going to suggest we do because this actually makes it easier. Continuous or discrete graph? Continuous. Well, let's just write that because right away, as soon as we know it's continuous, we know we're not going to be able to write it as individual x values and individual y values. We're going to have to use an inequality. We have to because we can't list them all. So what we're going to do is we're going to take and we're going to say, okay, well, here are the endpoints of this continuous graph, and we're going to name them right on the graph. Okay? So what's the first endpoint, the lower one? What's its ordered pair name?
-2 and 1.
Okay, -2, 1. Write that because that's going to be helpful. The higher one, the other endpoint, what's its ordered pair name?
2, 4.
2, 4. Okay. So remember, when you're writing the domain, you got to talk about what are all the possible x values. So when we write our domain, we're going to still start with a capital D in our little set notation. But since it has 2 endpoints, it's got to be in between something. Remember our and compound inequalities are in between. So we're going to have an x in the middle. And since there were no like open circles at the ends of that, we're going to say, well, then they're closed in circles. So we're going to have our equal to bar included in our inequalities. And they need to go that direction because when we read it inside out, we're saying x has to be greater than something and x has to be less than something. So what's to be greater than something, what's the endpoint? It's kind of like, think of it like this. If we were drawing this on a number line like we did when we graphed them, what would be the endpoints for the domain? What would be the endpoints for the domain? -2 and 2. So what we're really showing here is this compound inequality. So what are we going to put here?
-2.
-2, and we're going to put a +2 here. Okay? Now I want you to try that with the range.
Can we put the range on the other one?
Yeah, that's what I'm going to do too, because I'm out of room. What's gonna go in the middle of the range? Not x's, but y's. These are y's. And again, we're gonna have our inequality symbols that say, well, y has to be greater than something that we're gonna put at the left end, and it has to be less than something that's at the right end. It has to be somewhere in between those. So you know what? Even though the y's are vertical on here, in reality, well, you know what? Let's just draw it vertical just for the fun of it. What's the highest and what's the lowest the y values are gonna go?
1 is the lowest.
The 1 and the 4, right? Yeah. So this is really what we have. We have a number line just kind of, you know, going in wrong directions. It's going up as high as 4 and it's going down as low as 1. So should the 4 go at the left end or the right end?
Right.
At the right end. Yeah. Can't go any higher than that and it can't go any lower than 1. Okay? Go ahead now. First thing I want you to do on the next one, I want you to identify all the corners of that rectangle. Okay? It's going to be important that we know all this information. What are all of these corners? What are their ordered pair names? So go ahead and do that first for me. So not any points anywhere else, just the corners where it doesn't go past that, whether you're going horizontally or vertically. And after you've named them, I want you to look up and see if you and I agree. I'm just going to draw a number line before I try and write my inequality statement here. What's the endpoints for the x values? So domain, let's just draw this little graph like we were doing over here to help us out. What's the endpoints for our compound inequality for the x's? Andrea? -3 and 2, yeah. So it doesn't go any further than -3 this way. Both those points have a -3 x value. It doesn't go any further than 2 going to the right. Both those points have an x value of 2. So it's really, the x values are all between -3 and 2 and including those guys. So when we write our compound inequality for this, we'll have -3 has to be less than all of the shaded region, which is x, and it also has to be less than, or no, -3 has to be less than the shaded region, and the shaded region has to be less than 2. If we read it from left to right. If we read it from inside out, it says x has to be greater than -3, that's what this is, and it has to be less than 2, that's what's happening. Okay, you try the range now. Draw the number line thing, try that, remember it's vertical. Try the range now on your own, see if you can get that. And again, it's vertical, so think about what's the highest it goes, what's the lowest it goes. These will be the ones that'll challenge you the most in the homework for domain range. Okay, Adam, you look like you're done. What's the highest it goes?
It would be 3
3
and 1.
and 1. Okay, you guys agree? So it doesn't go any higher than 3, it doesn't go any lower than 1, and it doesn't go anywhere in between. So those are the line segments on the side, aren't they? Yeah. So what are we going to write here?
1 is less than or equal to y.
Good job, good catch.
And then y is less than or equal to 3.
There you go, good job, Adam. Okay, there's our compound inequality that represents the range. All the y values on any of those line segments are between 1 and 3, and they include 1 and 3. All of the points on any of those line segments of that rectangle are between, the x values are between -3 and +2, and no more than that. Okay, anybody have questions on that? Because again, these are going to be the ones that are going to challenge you on the homework, and I don't want you to just write something down. I want you to actually process through. Okay, let's go to the back then. Let's do functions now. Okay, I want you right now to put just a big box around this. This is, and then I want you to, even better yet, I want you to double underline each x value can be paired with only one y value. And this is the important part right here. The x value is what we're going to pay attention to. Is each x value paired with only one y value? Then we can say that that relation is a special relation called a function. So in the ones that are already done here for us in the examples, they have the ordered pair. That this is one. This is a different one, and this is a totally different one. We got 1, 2, and 3. Okay. In 1, 2 is only represented once in the whole table, so it only has one y value. 3 is only represented once in the whole table, so it only has one y value. 4 is only represented once in the whole table, so it only has one y value. 5 is represented only once in the table, so it only has one y value. Okay? Don't worry about that these 4's match here for the y's, because that isn't what matters. It's the x's. Are they only paired with one y value? Okay, when we look at it, when we look at the graph, here's a really easy way to tell on a graph. Do you have any points on the same vertical line above and below each other? So this one is the only one with an x value of 2. So it only has one y value. Here, this would be 3. It only has 1. There's no other points that have an x value of 3. Here, this one doesn't have any other points that have an x value of 4. And this one doesn't have any other points that have an x value of, okay, it looks like they graphed this one, didn't they? I didn't even realize that. Okay. And the third one, how do you feel about that one? 2, how many y values is it mapped to? How many y values is the 2 mapped to? 1. Only 1. How many y values is the 7 mapped to? It only has one arrow going out from it. How about 8? 15. Oh, but look over here at this one. 6 has 2 arrows going out from it, doesn't it? It has a y value of 7 and a y value of 10. Look at on the graph what happens when it's not a function. Look at there. There are 2 points that have an x value of 3. Look at our table here. We have the same x value twice. And these y values that are going with them are both different. So if these are not functions. These are examples of not functions. So let's go down and see if we can do it now. Number 7. How do you feel about that table of ordered pairs, that relation? Do you think it's a function? No, why not, Samuel? Okay, it has 2 negative 3's, but more, and just as importantly, not only are there 2 negative 3's for x, but there are different y values for them, right? So we have negative 3 that can be mapped to 2 and to 3. So we're going to say not a function, and we're going to be specific. We're going to say the x value negative 3 has 2 different y values. So it's the domain value that makes it break down from being a function. It's just going to be an ordinary old relation. So you have to explain like this. You can't just say no or yes. And you can't just say because it has 2 x values the same. No, you have to say because the actual x value of negative 3 has 2 different y values. Okay, number 8. What do you think about that one? Is that one a function? So what do we zero in on? What do we look at first? The x values. So does our x value of 4 have more than one y value? No. It's mapped to 5. Is it mapped anywhere else? How about 8? Does it have more than one y value?
Yeah.
Okay, what are its y values then at 5?
4 and 5, there would be 2 5s in
No. X is the 8 is the x value, and it's only mapped up to that 5. It doesn't matter that 4 has got it also. It doesn't matter that they're sharing it. We're talking about, does each x have only one y? How about 12? Is it mapped to more than one y value? How about this 16? Okay, is this a function then? Yes, is a function. Each x value has only one y value. That would be how we would explain a function. That's the definition. Each x value can only have one y value. Okay, now to number 9, we have a continuous graph. Continuous graph does not mean it will, just because we write compound inequalities, there's a ton of different x values, that don't mean it'll always be a function or it will always not be a function. You have to make a decision about, are there any places on that continuous graph where you have an x value that has more than one y value. So, I'm thinking right here, at the tip of that triangle and on the base of the triangle, we have ordered pair 3, 3. We have ordered pair 3, negative 1. Does that x value of 3 have more than one y value? It does, doesn't it? So is this a function? No, this one is not a function. So all you have to find is one place where it actually breaks down. All you're going to find is one. It doesn't take a bunch of them. It only takes one. So we're going to say not a function. The x value, you know what? We're going to even get more specific than that because we're smart enough. Not only is 3, but anywhere like along the way here, I'm going to pick another spot. There's another spot where up here and straight down below it, there's one. I'm going to pick another spot. Right here and right there, there's another one right below it. But how about this one at this end right here? Does this one have another one above or below it? No. How about this one? Does this one have another one above or below it? So we're going to say, not a function, the x values between 1 and 5 have 2 different y values. All of those do. Any x value you would choose between 1 and 5 would actually have 2 different y values. We get a whole bunch of them that break it down, don't they? Okay, questions on being able to decide if it's a function or not and how to explain it. Okay, think you got this? And then domain and range, how about back to domain and range? Anything unclear that you want clarification on with that yet? Okay, then it's homework time.